Hi, I'm Kim Tutin from Georgia Pacific. Emissions controls technologies today rely primarily on a process called oxidation. This means that users have to heat the air to very high temperatures to burn up the emissions. This uses a tremendous amount of energy, creates greenhouse gases, and is very expensive to operate. The alternative solution is a technology that utilizes a fluidized bed of activated carbon to very efficiently adsorb those emissions from the air at the temperature that it comes out of the process. So it uses a lot less energy. Now, there are many potential sites where this technology can be utilized, including wood pellet and oriented strand board manufacturing. So what we want people to know is that users have a choice. Our testing indicates that this technology can help users to meet their air emissions control requirements, significantly reduce greenhouse gas emissions, drive down operational costs, and generate revenue from a valuable byproduct. So it's good for our air, and it's good for industry. I hope you stick around to learn more. Thank you for continuing to listen in and learn more. I'm going to share with you our learnings regarding the use of bead-activated carbon in a fluidized bed concentrator, the FBC, to control emissions and recover terpenes from wood drying. The great thing about the FBC technology is that it's already commercialized in many applications, including automotive painting and electronics manufacturing. In the current commercial applications, the FBC technology has already demonstrated very good operational reliability. For example, it has no large, heavy moving parts that have to be replaced or repaired. In fact, the only moving parts are the fans that move the carbon through the system. Also, the FBC is made from stainless steel, so it resists corrosion. The FBC is only new to wood drying, and for that application, Georgia Pacific Chemicals has already filed 2 patent applications. The FBC technology has already been recognized by state environmental agencies for excellence in environmental performance. For example, Honda Motors of Alabama was honored as Air Conservationist of the Year in recognition of the company's efforts to significantly reduce emissions when they implemented the FBC to increase production. Now let's look inside. Process air containing emissions enters the adsorber. It passes up through a series of trays filled with activated carbon beads. Just like the carbon or charcoal you probably use in your house to clean your drinking water, activated carbon cleans the air. When the emissions hit the carbon, it very efficiently adsorbs those emissions. Then the clean air exits out the top of the adsorber. The carbon falls to the bottom of the adsorber and is transported using air from the fan to pneumatically convey it to the desorber. In the desorber, the beads are heated to release the emissions. At the same time, nitrogen gas is moved across the carbon to sweep the emissions in vapor form to the condenser. The carbon moves to the bottom of the desorber and is conveyed pneumatically back to the adsorber, where it is reused again to adsorb the emissions. In the condenser, the vapors hit the very cold surfaces of the tube and shell style condenser to convert the vapors to liquid. The liquid is then collected and sold. Finally, a small amount of carbon is continuously fed to the side stream reactivator, where it is heated to over 1400 degrees Fahrenheit to remove any residual traces of organics that might accumulate on the carbon. This ensures the carbon remains clean enough to continue to adsorb the emissions effectively. Here you can see what the beads look like when they are fluidized in the trays. When the air flows through the holes in the trays that are full of beads, it fluidizes them, which makes them look a little like they're boiling. We ran pilot trials of this technology at a commercial-oriented strand board mill. As part of this demonstration, we did air stack testing. In these charts, you can see that we successfully met the PCWP max standard by reducing VOC emissions by over 90%. We demonstrated this twice during 2 separate testing events by 2 independent certified air emissions stack testing companies, which specifically were AIR, that's Advanced Industrial Resources, and John Zink Hamworthy Combustion. On this particular day, we demonstrated this 3 times in a row during each of the 3 one-hour tests. We also did a complete battery of air emission stack tests. Here you can see again that our testing indicates that we met the PCWP max requirement of greater than 90% reduction efficiency. In addition, you can see that we reduced HAPs by 75 to 85% and particulate by 50 to 65%. Interestingly, we did better at controlling the smallest particulate emissions, specifically PM10 and PM2.5. We also did really well at controlling SO2 and were able to reduce it by 99%. It's very important to understand that this emissions profile is probably different than what any one of you have in your specific permits today. But given the reduction in greenhouse gas emissions and the recovery of a valuable byproduct, agency personnel have told us that they would happily accept these emissions trade-offs. These findings were reviewed with 2 state environmental agencies and 1 expert from the EPA. In our discussions with environmental personnel, they were supportive of permitting for the full commercial unit. In addition to controlling the emissions, we also collected terpenes. Terpenes are in the sap of pine trees, especially southern yellow pine. Terpenes are the primary constituent of emissions from drying pine wood. So when we adsorbed, desorbed, condensed, and collected the emissions, we collected these terpenes. These terpenes are responsibly covered, bio-based materials, and they can be sold as fragrances, solvents, fuels, etc. For industry, one of the best parts of this technology is that our testing indicates it enables them to significantly reduce the operating costs for their emissions control device. Here you can see that they don't need to use any natural gas because we don't have to heat the air to control the emissions. Also, it uses significantly less fan power to move the carbon because the carbon media is fluidized instead of packed. This makes it much easier for the fans to move the air through the media, so reduces the amount of electricity required to run the system. So, overall, including capital, maintenance, and operating costs, the total cost of ownership is significantly reduced as compared to oxidation technologies. Here you can see that our testing indicates that greenhouse gas emissions are significantly reduced when running the FBC as compared to an oxidation technology such as the RTO. Greenhouse gases are created in 3 ways by emissions control technologies that oxidize the emissions to control them. They create CO2, 1, by oxidizing the very emissions being controlled, 2, by burning natural gas to heat the system to oxidize the emissions, and 3, by the fuel required to make electricity to run the system. By contrast, the FBC collects rather than oxidizes these emissions, so uses no natural gas and uses significantly less electricity, so creates significantly less greenhouse gas emissions. Our testing indicates that the FBC technology can be used in many locations where wood is dried to make a variety of wood products, including wood pellets, oriented strand board, plywood, etc. You can see the many potential sites on this map. So, our pilot trials were very successful. We met the PCWP max requirement of over 90% reduction efficiency, collected terpenes, and demonstrated good operational reliability. Our final step to full commercialization of this technology is to scale up to a full-size production unit. We're talking now with a number of wood products manufacturers and look forward to taking this final step. Last but not least, we have a great team. Hal and his team at Environmental CNC have already successfully commercialized this technology at over 60 sites worldwide. This team has the capabilities, the integrity, and the passion to deliver. I hope this gives you a much better understanding of the FBC technology and much better appreciation of what it can potentially accomplish. Thank you very much for your time, and I hope you reach out to me to learn more. Thank you.